Hi everyone! Today we will learn about definition 7, the negative binomial distribution, another important discrete probability distribution. But before anything else, let's take a look at first how it relates to other important discrete probability distribution, specifically in geometric distribution and binomial distribution. So let's go first to the geometric distribution. Geometric distribution is the distribution of the number of trials needed to get the first success in repeated independent Bernoulli trials. But negative binomial distribution generalizes this one. Negative binomial distribution is the distribution of the number of trials needed to get the art's success in repeated independent Bernoulli trials. So if we are interested in the number of trials to get the fifth success, then R would be equal to 5. If we are interested to get the number of trials in the seventh success, then R would be equal to 7. But it simply depends on the problem given ahead. So always remember that geometric distribution is in the first success, and negative binomial distribution is in the art's success. Second is binomial distribution. A random variable that has a negative binomial distribution can sometimes be confused for one that has a binomial distribution, and that confusion can cause some problem. So let's take a look at how these two differs from one another. Binomial distribution is the distribution of the number of successes in a fixed number of independent Bernoulli trials. The number of successes is our random variable x, and the fixed number of independent Bernoulli trials is our n. While in the negative binomial distribution, x is the number of trials needed to get a fixed number of art's success. Again, in binomial distribution, random variable x is the number of successes, and n is the number of trials. But in the negative binomial distribution, n is replaced by r, which is the number of successes, and random variable x is the number of trials. In other words, negative binomial distribution refers to the probability of the number of times needed to do something until achieving a fixed number of desired results. Sometimes, negative binomial distribution is described as the distribution of the number of failures needed to get a fixed number of successes. But we're gonna use the definition here. So what we're interested in is the probability distribution of the number of trials needed to get this fixed number of successes in repeated independent Bernoulli trials. Let's break down the idea about independent Bernoulli trials a little bit further. Suppose we have independent trials, and each trials results in one of two possible mutually exclusive outcomes, and we're gonna label those as success and failures. The probability of success on a given trial is little p, which stays constant from trial to trial. The probability of failure is simply 1 minus p, and the capital X is a random variable representing the trial number of art's success. In order for the art's success to occur on the X trial, we need a couple of events to occur. First of all, in the first x minus 1 trials, we're gonna need to have r minus 1 successes. And we can calculate the probability of that using the binomial formula. And this is just the binomial formula here. But we also need the x trial to be a success, and that has a probability of p. And to calculate the probability the art success occurs on the X trials, we're gonna simply multiply the two probabilities together because the trials are assumed to be independent. So then the probability of random variable X takes on the value of little x is the product of two probabilities I had just mentioned. So we multiply them together and simplify them a little bit. And then we have our probability mass function or our PMF for the negative binomial distribution. For x is equal to r plus 1, r plus 2, and so on because it has no upper bound on it. R is the smallest possible value of x. If we're gonna need R successes, we're gonna need R trials. To understand further the negative binomial distribution, I have here an example. A person conducting telephone surveys must get 3 more completed surveys before their job is finished. On each randomly dialed number, there is a 9% chance of reaching an adult who will complete the survey. What is the probability the third completed survey occurs on the 10th call? So by this example, we can apply negative binomial distribution. So since our problem is to get the probability the third completed survey occurs on the 10th call, our x would be equal to 10 because we are up to the 10th call, and our r is equal to because we are up to the third completed survey, and since there is a 9% chance, our p is equal to 0.09. So we will use the probability mass function derived earlier. So by that equation, we will just simply substitute the values and then simplify it. And if we have calculators, we can just input it directly, and then the result would be 0.01356187619. So that's all for today. I hope you've learned something from this video. And by the way, I am Diosa Pastrano, a BS Ed Mathematics 4th year student of Central Mindanao University. Goodbye and God bless!